All right, guys, if you've ever watched a video closely, this is the one to watch closely. We're going to multiply polynomials some more like we did yesterday, but we're going to use something called Pascal's triangle because the polynomials we're going to multiply are like huge. So like hang in there, get as much of this as you can. Obviously, we'll do it in class tomorrow and you'll feel good when you leave, but like the better you can come prepared tomorrow, sorry, the better off you are. All right, here's what it looks like. If you have a binomial in here and it's raised to a zero power, obviously anything to zero power is one. I think you know that. So over here is where Pascal's triangle is. I'll kind of relate that as we go through. Anything to the first power is itself. So if you do a plus b to the first power, you just get a plus b. If you think about that, both coefficients are 1. Okay, so 1a and 1b. If you have a plus b squared, we did this shortcut the other day. Remember, square, multiply, double square. That's what that is. And if you look at the coefficients are 1, 2, 1. I'm going to talk about the triangle more in just a second. If you do a plus b cubed, this is what you get. Look at the coefficients, 1, 3, 3, 1. First of all, they're symmetric. 1, 3, 3, 1. If you raise something to the fourth power, a plus b to the fourth, you get 1, 4, 6, 4, 1. As I'm going through this too, also notice the exponents. The exponent on the a are going down as we go. The exponents on the b start coming up as we go. And the coefficients go 1, 4, 6, 4, 1. One more. A plus b to the fifth. Look at the coefficients. 1, 5, 10, 5, 1. There's Pascal's triangle with the 1, 5, 10, 5, 1. But one more time. Look at the exponents on the a. A5, A4, A3, A2, A1. No a. Now look at the b's. No b, B1, B2, B3, B4, B5. So the a's are going down. The b's are coming up. And again, the coefficients are symmetric. All right, now here's how the triangle works. It's pretty cool how it works. If you look at the numbers in the triangle, which represent, and you just look at the coefficients are symmetric. But if you look at where they come from, where the triangle comes from, for example, if you look at this 2 right here, that 2 came from those two ones. 1 plus 1 is 2. That 3, 1 plus 2 is 3. 2 plus 1 is 3. That 4 right there, 1 plus 3. That 6, 3 plus 3. That 4, 1 plus 3. This 5, 1 plus 4. That 10, 6 plus 4. That 10, 6 plus 4. That 5, 4 plus 1. And you have 1s all around the perimeter of your triangle. And that's where the triangle comes from. Okay, so I'm going to show you what we're going to do with that to expand some of these binomials. I'm going to show you two examples real quick. Okay, the first one says x minus 2 to the fifth power. Because I'm looking at a fifth power here, I'm going to draw the tree, Pascal's triangle. 1, 1, 1, 2, 1. Again, the 2's because of 1 plus 1. 1, 3, 3, 1. I'm just adding the numbers above. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5. Now, I could keep on going and going, but as soon as I see that 5 right there, it matches up with that 5. That's all I need. Now, one thing to look at here, one more pattern. That row contains 6 numbers, which means my answer when I expand this is going to have 6 terms. So I'm going to start right here. I'm going to start with x to the fifth power. That's how we're going to start. My next coefficient is a 5. Now, because there's a minus sign in there, I'm going to put a minus sign in the front. The minus is going to make the signs alternate in my answer. So I'm going minus 5. The x is going to come down. The 2 starts coming up. The next coefficient is a 10. It's positive. Their sign is going to alternate. So I'm going 10. X is coming down. 2 exponent starts coming up. There's another 10. It's a minus 10. The x is coming down. The 2 is coming up. I'm running out of room. I'm going to erase part of this tree right here because I already know what the tree said. And the next one is going to be a plus 5. The x is coming down. The 2 is coming up. And it's going to end up with a minus and just 2 to the fifth power. Okay, so I hate I had to erase that fifth line. But anyway, to finish up, you can't leave numbers everywhere. So what I'm going to do is I'm going to actually multiply the numbers. Like that 2 times the 5 gives me 10. X to the fourth. This is 2 squared. 2 squared is 4 times the 10, 40x cubed. This is 2 cubed. 2 cubed is 8 times 10, which is 80. That's 2 to the fourth. 2 to the fourth is 16 times 5, which is also 80. And then 2 to the fifth is just 32. That's where we're going. It's going to take you 2 lines usually. 2 big lines, to be honest with you, but there you go. I'm going to show you one more. If you didn't get this one, which there's a good chance you didn't, and that's okay, see if you can get the next one a little bit better. Here we go. Draw another diagram. Pascal's triangle, sorry. 1, 1, 1, 1, 2, 1, 1, 3, 3. That's what I was waiting on. I was waiting on 3 because that exponent is 3. So I'm using this row. So my coefficients are going to be 1, 3, 3, 1, 4 terms. Okay, so I'm going to use the 1 first. 1, I'm going to do the 3y to the third power. There's really a 1 in the front. You don't need to write the 1 in the front, but there's really a 1 there. Because there's a plus sign in here, everything's going to be plus. My coefficient's going to be 3 for my second term. The 3y is coming down, not a plus sign. The 1 is going to start coming up, so 1 to the first power. Keep going here. The 3 is next. The 3y is coming down to the first power. The 1 is coming up. And the last term is going to have a 1 as a coefficient. So you don't have to write the 1, and there's no more 3y's, so just get 1 to the third power. Now your job is to multiply this stuff out. Remember, 2 lines and you're done. This 3 right there goes for everything inside. I'm going to cube both those things. That's going to be 27y cubed. The 1 I don't care about because 1 times anything is just 1. I'm going to square 3y, that's 9y squared, times that 3, 27y squared. The 1 again, I don't care, still 1. 3 times 3 is 9y, and 1 cubed is 1. Okay, and there's your 2 lines, there's your answer. Now, looks weird, different from anything you've probably done before, and we're going to work on it like we always do. There's one thing else I was going to tell you about the pattern, but it left me for a second. Oh, here's what I want to tell you this. The exponents down here, like there's a 3. Look at the main exponent. That was a 3. The exponents here are 2 and 1, which add up to be 3. The exponents right here are 1 and 2, which add up to be 3. The exponent there is 3, which is 3. Okay, so that's always going to be true as well. We'll talk about more about the patterns tomorrow and get you really good at this. At least I hope we do get you really good at this. I hope you're here. I'll see you then. We'll fix it. See ya.